so I said I will do an algebra and trig video, so here we go. So I don't know your math skills, I'm not aware of it, so I will assume the very minimal. So I think for algebra 1 or things like that, I think I will just solve some few math problems from the 2015, 2016, 2017, all the way up to 2019 SATs. So the problem 1 really asks is if x minus 1 over 3 is equals to k, and k equals 3, right? And k equals 3, what is the value of x? Right? This is a straightforward question. What we do is we plug in k equals 3, right? So what we do here is we say x minus 1 over 3 is equals to 3. When we have a denominator like this, right? What the hell? Okay, when we have a denominator like this, right? We multiply by 3. So we multiply here, so we do something like this. We multiply here by 3, right? And then if you multiply by the left side by 3, you multiply the right side by 3. So 3 times 3, right? So here we get is, well, x minus 1, right, is equals to 9. And then if you add plus 1 on both sides, right, and plus 1 on both sides, right, we get what? X is equals to positive 10. So what is the value of x? X is equals to plus 10. This is the answer. So this here means therefore x is equals to plus 10. Okay? That one was straightforward. Okay, so second one is a bit more complicated, but still pretty basic, I believe. So for I is equals to square root of minus 1, what is the sum sum 7 plus 3i plus negative 8 plus 9i, right? So I is an imaginary number. I'm sure you've heard about this in your algebra class somewhere. So, I mean, doing this problem is pretty straightforward, right? So this is 7 plus 3i, 7 plus 3i, right? Plus and minus, so we distribute, right? We distribute, and we distribute, right? So if you distribute this, right, we get minus 8, right? Minus 8 plus 9i, right? So we add with the i's, and we add with the non-i. So 7 minus 8. 7 minus 8 is equals to negative 1. 3 plus 9. 3i plus 9i is plus 12i. And this is the answer. Now, there's an interesting fact about this imaginary numbers. And in high school, the only thing you have to know is if I is equals to square root of minus 1, right? I squared is going to be minus 1. I cubed is going to be minus I to the fourth is going to be 1. Okay, so it follows a circle. This kind of follows a circular pattern. And so we can deduce basically saying that we can know higher powers of I using this pattern here. For example, let us say what is I to the, for example, 9th power without really thinking about it? Well, I to the 9th power, so it's I to the 4th, right? It's equals to I to the 4th, right? Times I to the 4th, right? Times I, right? To the 1, because remember that times I to the 1. So 4 plus 4 plus 1 gives 9, right? So I to the 4th here, this is 1, right? Right? I to the 4th here is again 1. Here is just I, right? So 1 times I is just I, right? And there are clever tricks that you can do. And for example, we can do the same thing for I to the nth power for any n being an integer. We can use this trick to actually do this kind of problems, which sometimes I heard it appears in the ACTs on my own research. I'm sad to tell you, but I cannot really do the word problems because the word problem is so long and it's going to take me forever to write them. But I will try to do the non-word problems as fast as I can, okay? So, I'll do some important word problems though. Okay, so the third one I want to do is from the real SATs. It's a real problem. From the previous exam is x squared y minus 3y squared, right? Plus 5xy squared, right? 5xy squared minus negative x squared y plus 3xy squared minus 3y squared, right? So what we do here is basically we have to simplify this expression or this polynomial expression, right? So we have this minus sign. So we have to distribute the minus sign to each one of them, right? And what we get in the end is we get this x squared y, right? Minus 3y squared. I mean, we just copied the first thing. Plus 5xy squared, right? Minus and minus is positive. So plus x squared y, right? Minus and plus is minus, right? Minus 3xy squared, right? Minus and minus is positive 3y squared, right? So here we have to simplify 5 terms. So x squared y with x squared y. So what we get? 2xy squared. 2x squared y, right? Whatever that is. This is 2x squared y, right? We have minus 3y squared with positive 3y squared, right? Minus 3 plus 3 is 0. So that term disappears. So here we go, right? We have 5xy squared, positive 5xy squared, minus 3xy squared. That is equals to 2xy squared, right? And yeah, we simplified the whole term. So the answer is this, right? Now, I want to do this word problem, which I think is a very clever question. So, not clever, but it's just a typical SAT style question. If I find it, I don't know how to say it, but yeah. So we have this formula: m is equals to what is this? R over 1,200, right? Plus 1 plus R over 1,200, right? To the nth power, right? Over 1 plus R over 1,200 to the nth power minus 1, okay? And times P, where if we classify these variables, right, P is the price in dollars. Price in dollars. R is the percent. R is the annual interest. Annual rate of interest. N is the number of months. And yeah, that's what we have to know. So our mission is to solve for P. Okay? Solve for P. We have an equation in terms of M, but we have to solve for P. How do we do that? Well. So, first of all, we want to put this P right over here. So what we're going to do is we're going to reverse it, okay? So we're going to find 1 over M, right? If you put 1 over M, well, we reverse this. So it's going to be something like this. 1, right? 1, right? Times R over 1,200, right? Times 1 plus R over 1,200 to the nth power, right? Divided by 1 plus R over 1,200 nth power minus 1, right? So because this is a fraction, we can reverse this, right? So remember that remember in basic algebra that 1 over A over B, where A over B are numbers, right, is equals to B over A, right? Right, remember this, right? So if you do that, right, this becomes what? Well, becomes times P. Where did I forget this? Times P, right? So this becomes what? This becomes 1,200 1 plus R over 1,200 to the nth power, right? Minus 1, right? Over R over 1,200 N, right? Times 1 plus R over 1,200 to the NP, right? So, I'm not going to write the P here. In fact, I'm going to just do it here. It's 1 over P, right? It's equals to 1 over M. Now, how simple is this? So now we multiply by M, both sides. So by M, right? And here we're also going to multiply by M, right? So we get, if you do this, we get that M over P, right, is it times R plus, 1 plus R over 1,200 to the N minus 1, right, times R 1,200 over N, right, 1 plus R over 1,200 over N, right? Oh, shoot. Sorry. There is no this. There's no this. So there's this. This is equals to 1. And if you multiply by P both sides, right? We multiply by p both sides, so this is going to be p, right? Is equals to m times 1 plus r over 1,200 n minus 1, right? Times r over 1,200 times 1 plus r over 1,200 n. Okay. So this will be the answer. So basically, this was basically solving for the variable p. Alright. Alright, now let's do another one. Oh, this one. Yeah, let's do this one. Give me a minute. So, this was number 4. Let's go to number 5. I'm sorry for all the noises I'm making. This should be loud. Let's go to number 5. If a over b equals to 2, what is the value of 4b over a? Right. And well, let's do this. Okay, so if a over b is 2, right? If a over b is 2, then b over a is going to be 1/2, right? So really, so here, 4b over a is really the same thing as 4 times b over a, right? So this is 4 times 1/2, right? This becomes 1, this becomes 2, right? And this is 2. This is the answer, right? Let's do number 6. Okay, so we were given the equation 3x plus 4y. Actually, I forgot to write this. We're giving a systems of equation, actually, of 3x plus 4y is equals to minus 23, right? 2y minus x is equals to negative 19. Yeah. So, how do we solve this? Well, the easiest method to solve any of these equations in SATs is an elimination. So, first of all, you have to find the common. So, let's switch this order up. So the 3x plus 4y is equals to minus 23, right? Negative x plus 2y is equals to negative 19. Well, let's try to eliminate x first or y first. Well, you can try with both. You can try either one, but I'm going to do y because it's easier. Okay? So if I want to eliminate y, then this has to be 4y, right? Because after all, we want to subtract this out. So to get this 4y, we have to multiply by what? By 2 in the bottom. So we get here, we get 3x plus 4y is equals to negative 23, right? And here we have negative 2x, right? Because we multiply by 2, and plus 4y, right, is equals to negative 19 times 2 is negative 38, right? So if we subtract, right? If we subtract here, right? So 4y and 4y is going to get away, right? And 3x minus 2x is 5x, right? Right, and this is equals to negative 23 minus 38, right? So this is going to be what? 5x is equals to what? Negative 23 plus 38, that's 15, and therefore x is equals to 3. That's our first answer, right? Now, if we have x equals 3, we can find other values. So let's plug this in to the first equation here. Let's plug into this equation, right? And we find is by plugging in, we get 3. We get 3 times 3, right? Plus 4y is equals to negative 23, right? So we get, after all, we get 9. 3 times 3 is 9. Plus 4y is equals to negative 23. And if you solve this equation, we can subtract 9, right? And we can subtract 9 here, right? I'm not used to this method, but I'm trying to do it. We get, and then therefore we get what? We get 4y is equals to negative 32, right? And therefore y is equals to minus 8, right? It's not that bad, right? Okay, so let's do another one. Let's see. 6, well, we're given a function, g of x is equals to ax squared plus 24, and obviously a here is just a constant. It's just a number. We have to define what a is, basically. So the question is, for the function g, defined above, a is a constant, and g of 4 equals 8, right? What is g of minus 4? Okay, so we're given that a is a constant, right? We know that a is a constant, right? We know that g of 4 is 8, and we have to find what g of minus 4 is, right? So let's first utilize the information given to us. Let's first utilize this information here, right? So if you use this information, g of 4, so you plug in 4 to all x. So here, a times 4 squared, right? Plus 24, right? What do we get? We get 16a plus 24, right? And what is that equals to? This is equals to 8, because g of 4 is said to be 8. Now, if you solve this equation here, right? If you solve this equation, we can find the value of a. So, solving the equation, right? Solving the equation, 16a plus 24 is equals to negative 8. Let's do this. We're going to minus 24 here, right? And minus 24 here, right? And then we get 16a, right? This cancels. This cancels, right? We get, well, minus, right? So negative 8 minus 24 is negative 32, right? So a here, so therefore a is what? minus 2, right? If a is minus 2, then we know that g of x, so if a is minus 2, then we know g of x is equals to minus 2x squared plus 24, right? Now, if we know this information here, right, we can find what g of minus 4 is. So let's find g of minus 4. So g of minus 4, right, is equals to negative 2 times negative 4 squared plus 24, right? So 16 times negative 2, this is negative 32, right, plus 24. So negative 32 plus 24 is equals to negative 8. Therefore, g of minus 4 is equals to negative 8. Okay? This is one other simple question we can solve easily. All right, now let's do this. So this is a word problem, and I do like this problem actually. It's pretty creative. All right, so let's do this. And these are the kind of questions that really appears in the SATs as far as I know. So B is equals to 2.35 plus 0.25x. C is equals to 1.75 plus 0.4x. And basically, simplifying the word problem, but B and C represent let's see, let's cut this off here. B and C represent the price per pound, L beef pounds, in dollars, I'm not going to write that word, of beef and chicken. Okay, beef and chicken, stupid. So this is beef. So this is beef. This is chicken. Okay, we get that. So X weeks after July 1st during the last summer, what was the price per, so basically, then we says, what was the price per pound of beef and chicken when it was equal to the price per pound of chicken. Just letting you know, beef is always more expensive than chicken, like almost always. So this will never happen in the real case scenario. But if this ever happened, let me know, because I'll go buy beef. Usually never happens. So we're gonna assume, right? So what's very important in this question is equal when per pound of beef, right? This was equal to the price per pound of the chicken. Okay, so this means that B can be equals to C. All right, and then we can find what value of X is. So if you find the value of X when B equals C, we solve the question. So if B equals C, we have what? We have 2.35, right? plus 0.25x, right, equals to 1.75 plus 0.4x, right? Okay. All right, now let's review how to solve this kind of equation. So, non-x with goes to non-x, x with goes to x, okay? So, here what we're going to do is we're going to move non-x with the non-x. So, we have 2.35 minus 1.75. So, I moved this thing over here, okay? And we have 0.4x minus 0.25x, right? So this is 0.60. 0.60 is equals to 0.15x, right? And we have to solve for x. So solving for x is gonna be equals to 4. So now what do we have to find? Well, we have to find the price of beef. So if x equals 4, what is the price of beef? So beef B was, right, is equals to 2.35 plus 25x, right? So suppose, let's write it this way. Suppose b of x, right, is a linear function of 2.35 plus 0.25x, right? So b of 4, right, we use this value here to say 2.35 plus 0.25 times 4 times 4, right? And we get this b of 4 is equals 2.35 plus, if you have 4 quarters, this is $1, right? So this becomes, after all, it becomes $3.33. So actually, let me rewrite this later. It's $3.35. So beef is $3.35. $3.35 per pound. Okay. All right. Great. Now let's do this one. Number 8. Okay. Let's do number 8. If x is greater than 3, okay, which of the following is equivalent? Which of the following is equivalent to right, 1 over x plus 2, right, plus x plus 3 over 1, right? Over 1, right? So let's do this. Okay. So how do we do this? Well, we have to deal with this first here. We deal with this one here first, right? So do this as well. We must have the first same common denominator, right? So the common denominator of this is x plus 2 times x plus 3. So here we have is 1 over x plus 2 times, what are we missing? We're missing this thing, right? So we're missing x plus 3, right? And x plus 3, right? And plus 1 over x plus 3. What are we missing? We're missing x plus 2's, right? Right, and this one over here. Okay, so now we have this. Ooh, okay, so we have this 1, right? And then we have this x plus 3, right? X plus 3 plus x plus 2, right? All over x plus 3 times x plus 2, right? So here, x plus x is 2x, right? This is equals to 1 over 2x plus 3 plus 2, that is 5, right? Over, now we use FOIL, right? So if you have x plus 3 and x plus 2, right, we distribute, or in high school we call this FOIL. X times x, that is x squared, right? X times this plus 2x, right? This, that's positive 3x. This, that's 6, right? So we have this x squared, 2x plus 3x is 5x plus 6, right? And then we have this x plus 3x plus 2 is equals to x squared plus 5x plus 6. And remember the rule that I told you, where is it? Here. Here, should be somewhere here. Oh, here. Remember this rule, okay? This rule over here. Remember this rule. And let's apply it here. So we reverse the function. So this is the same thing as x squared plus 5x plus 6 all over 2x plus 5, okay? And yeah, this is it for this one. Okay, that was pretty easy. All right. Okay, so we did that one. Let's do another one. Okay. 9, right? If 3x minus y is equals to 12, right? What is the value of 8 over x, 8 to the power of 2 over y? Okay. Well, let's see. So 3x can be equal to 12 plus y. And solving for x, we can get x is equals to 12 plus y over 3. Okay, so let's do that. So we have 8, right, of 12 plus y over 3, right, over 2 to the y's power, right? Now this 8 is equals to what? 2 cubed, right? So let's multiply this. This is 2 times 3 times what? 12 plus y over 3 over 2 to the y's power, right? So this eliminates, right? So we have 2 to the 12 plus y over 2 to the y's power, right? And remember, remember, a to the m's power over a to the n's power is equals to a times a m minus n, right? Just remember this, okay? So if we do that, then we have what? It's 2 to the 12th minus y, right? Oh, plus y, sorry. Plus y minus y, right? Eliminates, and we have is 2 to the 12th power. It's 2 to the 12th power, right? Interesting. And okay, not this one. Number 10. If ax plus 2, bx plus 7 is equals to 15, x squared plus cx plus 14 for all values of x, and a plus b is equals to 8. What are the two possible values? What are the two possible values? Values for C. Okay. So doing this, well, first of all, this is what you have to get. So first, I want to expand this out. So we have ax plus 2, bx plus 7, right? And you want to expand this out, naturally. So we have, if we expand it out, right, it's this times this, right? And this times this, right? So expanding out, we get is ab times x squared, right? X times x is x squared plus 7ax plus 2bx, right? 2bx plus 14, right? We know that a plus b is 8. Okay. We know that a plus b is 8. Right. So, to get 15, right? So we have to get 15 here, right? And we know that this has to be equivalent to 15. This has to be equivalent to 15 x squared plus cx, right, plus 14, right? So this means that ab times x squared has to be equals to 15 times x squared, right? And we know that 7ax plus 2bx, or you know what, let's make it simpler. So factor out an x here, so we get 7a plus 2b times x is equals to some cx, right? So what numbers a, b, which are numbers, give 15? The only number that gives 15 is 5 and 3. So suppose a is equals to 5, b equals to 3, right? So naturally, well, if a equals 5, what do we get here? We get 35. Well, we get here, so what? Let's do step by step. 7 times 5, right? Plus 2 times 3. Right? all this multiplied by x has to equals to cx, right? So now 7 plus 5, 7 times 5 is 35, plus 6, that's 41. So here we have 41x equals to cx. We divide everything by x, right? And then we have c is equals to 41. Right? Well, we found one of the values. Now we have to find two of the values. And the reason why we know this is true is because a plus b has to be equals 8. And if you see this, 5 plus 3 is definitely equals to 8. Right? So yeah, that's how you find c. And let me see, ax 7ax 2bx. Okay, now AB is this, right? So now suppose B equals 5, right? And A equals 3. Because after all, 3 plus 5, no. Yeah, 3 plus 5 is also equals to 8, right? 5 plus 3 is also equals to 8, but 3 plus 5 is also equals to 8. So this is also a possible combination. So we do the same thing. So we knew that we have an equation, some sort like this, 7a plus 2b, right, times x is equals to cx, right? So we do is, well, we plug in, right? We say 7 times 3 plus 2 times 5 x is equals to cx, right? So 21 plus 10, that is 31. 31x is equals to cx, right? We divide by x, right? And we get c is equals 31. So the two values of c that is possible is c equals 31 and c equals 41. Alright, I think I'm going to end for this video. And next video, I'll talk about trig for you. And probably the next video, I might do more problems like these. Alright, bye.